Right now, as you sit there watching this explainer, I want you to picture something. That hot cup of coffee resting on your desk, it's slowly going cold.
And at the exact same time, your room is naturally getting just a little bit messier, isn't it? Somewhere out in the world, a drop of ink falling into a glass of water is irreversibly diffusing into this chaotic, cloudy mess.
And tick by tick, you are getting older. But here's the thing I want you to realize. These are absolutely not separate random occurrences.
So what actually connects a cooling cup of coffee to the irreversible march of time? Well, they're the exact same event. They are driven by a single, inescapable rule of the universe, something much, much bigger than you might expect.
Okay, let's dive into this. That law is called thermodynamics. Now, forget about all the complex equations for a second. Thermodynamics is simply the science of energy. It's about where it comes from, where it goes, and why it can literally never be fully recovered once it's been used. Think of energy kind of like money in a bank account. You can move your money around from savings to checking, but every single time you make a transaction, the bank takes a little fee. Well, energy works the exact same way. Every time energy does something useful, like, say, an inefficient light bulb turning on or the friction of two pool balls hitting each other, a little bit of that useful energy is irreversibly taxed and lost as heat. It is forever, irretrievably gone into the universe. And honestly, that is our very first hint of something slightly sinister at play here.
So, let's look at Section 1. The rules of the game, Law 0 and 1.
We're going to keep this fast and completely free of intimidating jargon, I promise. We start with the appropriately named Law 0. It essentially says if two things are the same temperature as a third thing, they're the same temperature as each other. I know it sounds painfully obvious, right? But it's absolutely crucial. This is the fundamental rule that makes thermometers possible. Without it, the entire concept of temperature itself would be totally meaningless.
Moving right along, we have the first law. Energy cannot be created or destroyed, only moved. See, the universe has a completely fixed amount of energy. It's exactly like a game where the total score never, ever changes. It just shifts around between the players.
Take yourself, for example. Your body doesn't just magically create new energy out of thin air when you go for a run. It simply shifts the chemical energy stored in the food you ate into kinetic energy from movement and thermal energy as body heat. The total energy in the universe remains perfectly balanced. It just moves.
Now we enter Section 2, the arrow of time, the second law.
Okay. This is the rule that really moves us from the mundane into the profound. It introduces a word you've probably heard thrown around in pop culture, but maybe never fully grasped: entropy. Basically, entropy is a measure of molecular disorder, and the second law dictates that entropy always increases. Things naturally and irreversibly move from order to disorder, never the other way around. Think of a broken egg on the floor. You have never seen a broken egg spontaneously reassemble itself into a perfect shell, right? And you never will, because the universe explicitly forbids it. Or take a standard deck of cards. A brand new deck has one perfect, specific order. But the very second you shuffle it, the universe demands it falls into random chaos. And why is that? Well, because there are 8 times 10 to the 67th power ways to arrange those 52 cards. That is an unimaginably massive number. You will literally never see a shuffled deck spontaneously sort itself back into that one perfect order just by random shuffling, because statistical probability absolutely forbids it. Entropy is the irreversible arrow of time. I want you to let that escalate in your mind for a moment. Every single star that burns in the night sky, every breath you take, every single thought you are having right this very second, all of it increases the universe's total disorder. There is no reversing this. There are no exceptions. Without the second law, the past and the future would be physically indistinguishable from each other. Entropy is the entire reason time only moves forward. Which brings us to Section 3, the unreachable absolute zero, the third law. Now, this law builds our understanding of temperature's ultimate physical limit. It defines absolute zero. That's minus 273.15 degrees Celsius. This is the ultimate ground state. It's the temperature at which all molecular motion drops to its absolute lowest, quietest limit, a complete and total physical standstill. But here's the catch. It is completely impossible to reach. Think of it kind of like a race, where every step you take only covers exactly half the remaining distance to the finish line. You can step closer and closer, and you can approach it forever, but you can never actually arrive. Absolute zero is mathematically and physically unattainable, brief and incredibly elegant.
And finally, Section 4, the fate of everything.
We actually need to jump back to the second law for a second because there is a massive consequence to it that nobody ever really mentions. Because entropy always increases, because disorder always grows, the universe is inevitably heading toward a final state called heat death.
In the unimaginably distant future, that heat tax we talked about earlier, it's going to take everything. All energy will spread out perfectly, evenly across the entire cosmos. All temperature differences will vanish. There will be no hot, no cold, just a perfect, silent equilibrium. And when energy is entirely dispersed like that, no stars can burn, no life can move. Time itself essentially ceases to exist because, well, nothing can ever happen again. The universe won't end with some traumatic, cinematic bang or a spectacular collapse. It will end with a beautiful, terrifying, and completely silent equilibrium. Guys, this is not science fiction. This is exactly what the second law of thermodynamics predicts.
Which brings us all the way back, all the way down to Earth, right back to the mundane. Remember that hot cup of coffee from the very beginning of this explainer? The exact same law that will eventually bring the entire cosmos to a frozen, silent end is the exact reason your coffee goes cold. Every drop of warmth that leaves your cup is entropy doing its work. It's the universe redistributing energy, tick by tick, toward its final, silent state. So, the next time your coffee goes cold, what other cosmic forces will you notice hiding right there in plain sight?